Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the Aurora Borealis, also known as the Northern Lights. And here to tell us all about it, from the Michigan Aurora Chasers, Melissa Kaelin. Melissa, welcome to the show.
Thanks so much for having me. It's a pleasure to be here.
Well, I was going to say, we're glad to have you. Now, before we get into the heart of it, tell our viewers a little bit about yourself and how you got interested in auroras.
Yeah, so I'm originally from Ohio, and I lived in Minnesota for 11 years. And it wasn't until I was 27 years old and I was living in Minnesota that I realized we can see the Northern Lights here in many of the U.S. states on a really regular basis. This was long before the solar maximum months hit, and so I saw a photo one night that was taken, turns out, right in my backyard while I was sleeping, and saw the caption said, "Oh man, I have to see this for myself. I have to learn everything I can."
So that was your introduction.
That was, yeah. It's been a long journey since. I've discovered a lot of beautiful aurora, a lot of excellent talents in the community, and a lot of opportunities. So
you've traveled quite a bit in this capacity.
I have, yeah.
Great. Well, for our audience members who might not be familiar, what is an aurora?
Yeah, so aurora is, it all originates on the surface of the sun. It's solar activity that is released or ejected from our sun toward the earth. That becomes space weather that then comes hurtling at us through space. And when that hits Earth's magnetic field with the right conditions, that produces the aurora through a process.
Exciting, the elements in the atmosphere, the molecules?
That's right. What's happening is when those particles from the sun and the solar wind hit Earth's atmosphere, they collide with molecules of oxygen and nitrogen, different air molecules, to emit color and light. And that's what creates the aurora.
Okay. So typically we see like red and green, so that would indicate the different elements?
Definitely. So the different colors that you see in the aurora are determined by the different molecules that those electrons and particles are hitting. So when we see aurora at high altitudes, that is often caused in a red color by those particles hitting oxygen at high altitudes. At lower altitudes, oxygen, when it collides with these particles, often emits a green glow. And there are many different molecules that can create many different combinations of colors.
Okay, so that's why we can see those varying colors in the aurora. Now, when is the best time to catch one?
Sure. You're going to want to go out when the skies are truly dark and we have true darkness, and that actually happens at astronomical twilight. We start to get some of our best dark skies. Aurora produces this glow that can only be seen at night, and so the darker your skies, the more of this color you could potentially see in the sky. So go out 2 hours before or after local magnetic midnight. Those are some of the peak times, or whenever we know a big impact of space weather is coming at us.
Okay, we've got that coronal mass ejection heading towards Earth.
Right. We can get aurora from a number of different types of solar activity, and this is all called space weather. One is a coronal mass ejection from maybe a solar flare or a filament eruption, and another type of aurora is when we see these high-speed streams of solar wind from coronal holes. These are all different types of space weather that actually are more than pretty colors and lights in the sky. This space weather has impacts on different parts of our infrastructure. It can cause satellites to shake, this geomagnetic activity, as we call it. It can cause disruptions in our satellite-based communications, and it can even cause your GPS to falter.
Oh my! So if it's strong enough, it can start to mess with all of our electronics.
Absolutely.
Oh my! Of course, you mentioned dark skies. Of course, if we're here in southeast Michigan, which is a challenge with all of the light pollution. But I imagine it would be helpful to not have the moon in the sky?
That's true. Yeah, when you're chasing aurora in the polar regions in places like Scandinavia, Alaska, or even northern Canada, you can see aurora almost any night, any time that we have darkness. But in the mid-latitudes, like places like Michigan or the Great Lakes region, we do better with low moonlight. So a new moon, one of those moon phases that doesn't have full illumination, that's going to give you better darkness in your skies. Also, getting out of the city, getting out of light pollution, that can help you see more aurora as well.
I know from where I live here in Metro Detroit, I've tried to catch some of the ones earlier this year, and I was not very successful. So.
That's true. It really helps to be farther north to catch the northern lights as well.
Now, how long do these events typically last?
Yeah, that's a good question. These events can last sometimes all night from sunset into sunrise, but often when you're looking for aurora at lower latitudes, these can be really brief. In fact, we've had some of our aurora chasers in the Michigan Aurora Chasers catch northern lights that shot up with pillars into the sky for only 5 or 10 minutes locally. Really? Yeah, very brief.
That would happen the farther south?
That's true. Yep. The farther north you go, the more likely you are to see more of the northern lights or to see it coming overhead. And sometimes those types of displays can last 20 to 30 minutes, maybe up to an hour. They'll come in waves and there will be lulls in between some of the aurora displays that you see.
So that sheeting or curtaining effect is more noticeable the farther north you get?
That's true. Yeah, you can probably see some of those pillars anywhere when the aurora is strong enough and we get these geomagnetic storms, as we call them, that bring aurora farther south. But there are many different types of aurora. You can see the veils and the sheets, as you mentioned. You can see corona overhead. You can see waves or undulations, many different types.
Oh my, that's quite a bit to be able to take in. I know from my own personal research, Native American culture was very tied into the aurora and their stories that went along with them. It's really a fascinating read if someone gets the chance to do that.
Definitely. I love the culture too. And so many of those stories are sacred stories that Native Americans have kept for the winter season when they really believed it was the peak season for aurora. And they tell those stories then. There's also some mythology, out in Europe where in Greco-Roman mythology, they talk about the aurora being the goddess of the dawn, whose job it is to escort the chariot of the sun god Apollo into the sky. So if you're trying to catch the aurora and you haven't seen it yet, maybe don't go out in the evening, go out at 3 o'clock in the morning or right before dawn.
Oh, okay. Okay. Well, it's interesting that the phenomenon of the aurora is seen in so many different cultures.
It really is, yeah. You can see the northern lights, which emanate from the North Pole, and during really strong displays, they push farther southward. Or you can see the southern lights, or the aurora australis, that emanate from the South Pole and push farther north.
Of course, being on the north side of the equator, we typically hear about the northern lights, but that's true. The same phenomenon can occur in the southern hemisphere as well.
It also happens on many other planets.
That's true. Yeah, we've seen some of the pictures with Jupiter and Saturn, I believe. It's got
Yeah,
the
for sure.
auroral displays around their poles as well. Mm-hmm. Yeah. Now, what types can you see?
Yeah, we talked about some of the types already, but there are a couple other formations that you can see. One of them I mentioned very briefly is the corona that takes place overhead in the night sky. That's really when the aurora converges in the apex of the sky in the middle of the night, or whenever the storm is strong enough, the geomagnetic storm that is. We're also looking at here a subaraural arc. There are many types of subaraural arcs that form a little bit more to the southwest, sometimes in the west, sometimes in different regions of the night sky. This one is called a stable aurora red arc, or a SAR arc, and the Milky Way is going right through it in this photograph. Those were seen a lot last summer.
Interesting. That's a fantastic photo.
Yeah, and here we've got a photo of a corona, which, I've just been going on and on about, but you can also see in this image, if you look really closely, a fragment, or a fragment-like aurora emission.
Is that little green.
Yeah, it's also called a FAAC, and this image from the Michigan Aurora Chasers caught a FAAC in Michigan for the first time in known history in 2024.
Oh, they're that rare.
Very rare.
Oh my.
Now, this is another subaurora arc. This is called STEVE. It's an acronym that has become a backronym. It now has words to it. The Strong Thermal Emission Velocity Enhancement. And so STEVE is kind of this mauve or pink or purple ribbon. Sometimes it looks kind of white in the sky. And it also comes with this really distinctive picket fence, which is its own aurora, those green stripes. And those will sort of play like piano keys in the sky when you see it in real time.
Fascinating.
Yeah.
Fascinating.
And so in this image, we can see some of the pillars really rising up during a strong substorm of the northern lights in an expansion phase. The aurora goes through 3 phases. It has onset, expansion, and then recovery after it performs a really big show. And so we watch it go through those phases every time we watch an aurora display.
And as it fades, then less and less of that solar energy is reaching the Earth's atmosphere?
Yeah, what's happening is that solar wind and all the particles inside the solar wind are hitting Earth at really high speeds with really high impact and high density. And once they charge up the particles in Earth's atmosphere, and that creates a lot of activity and tension and emits a lot of color and light, and then that does sort of fade over time as that impact finishes. It can always start up again, or we can get another gust of solar wind, and so aurora can be really unpredictable.
Interesting. So you could see a strong display, have it fade, and that's not necessarily the end.
Yeah, stay out longer, you may see round 2, maybe even round 3.
You never know. Well, this has been an interesting conversation. We do have to take a quick break. If you have a question, please send us an email. The address is down there at the bottom of your screen. And we'll be right back after Term of the Month with Stephen.
Thanks, Don. The term of the month is local bubble. That the sun is at the center of a low-density bubble in the Milky Way isn't a new idea. It's called the local bubble. It's classified as a superbubble due to its size, which is at least 1,000 light years across, and because it has a neutral hydrogen density of about 0.05 atoms per cubic centimeter. That's about 1/10 of the density of the Milky Way's average interstellar medium. The material that is there is super hot, about 1,000,000 degrees Kelvin. The local bubble isn't a sphere. It's flattened to the plane of the galaxy and sort of elliptical. Despite the sun being at the center, it isn't the cause of the low density. The local bubble was caused by supernovae that exploded between 10 and 20 million years ago. It was caused by exploding stars, like the explosion that created the Crab Nebula. It wasn't one supernova. Stars form from gas clouds near the same time as each other. The large stars that explode go through their lives in about the same 10 million years. Various radioactive isotopes, notably iron-60, are created in supernova explosions. The ratio of the isotope to the decay products give you an estimate for when the explosion took place. Sediments on the ocean floor and in Antarctica show explosions in the 2 to 3 million years ago range, around 7 million years ago, and as late as 9 million years ago. The sun moved into the bubble starting around 5 or 10 million years ago and has now reached the center. The bubble expands as the sun moves into it, as shown here. And that's the term of the month, local bubble. Back to you, Don.
Thanks, Stephen. We're back with our guest, Melissa Kaelin from the Michigan Aurora Chasers. Now, Melissa, since we're going out at night, what do you need to know before you go out?
That's a great question. We really encourage people to scout out a good location with a northward looking view before they go out in the dark. A lot of aurora chasers are trying this for the first time, or they've maybe only watched the northern lights a couple times. It helps to know the lay of the land. Get out there when you can see everything, when you can figure out where you want to set up your camera or set up your space for viewing, and you can avoid any hazards if there was flooding during the day, or if maybe there's an animal nest nearby or things like that. If you visit your location in advance, you can really watch out for those things. It also gives you an opportunity to find a really great composition for photography. So go out to a new spot during the daylight, find exactly what you want to frame in your photograph, and then you'll have the perfect shot when you set up that night. What else to know? It's an outdoor immersion activity. So a lot of astrophotographers and astronomers know this, but sometimes you need to dress warm, come prepared. A lot of the really great aurora happens in the winter time. So we like to encourage folks to bring emergency supplies or have some water and snacks in the car. There's a lot of ways to stay really safe when you go out about it. And then you can also watch your lighting. Any lights that you have on as you're going out to chase the aurora are not only going to obscure your night vision and make it harder for you to see the aurora, but they also might interfere with someone else's experience of watching the northern lights. So turn off as many lights as you can.
Use red lights.
Use red
Astronomers,
lights.
we know that very
yeah,
well.
absolutely. If you can, invest in a red light headlamp. Just some some good things that astronomers already know. So.
Yeah, it's a good idea, as you say, to scout out your location. If you're going out by yourself, tell somebody where you're going to be.
Yeah, absolutely.
And just a safety factor, always good to somebody knows where you are.
Yeah, it's good to tell someone where you are, where you're going, maybe a couple different spots you plan to check out, and then what time you plan to be back, so that if you're not back in time, they can check in on you. One of the things we've done in the Michigan Aurora Chasers, which is a group I founded in 2021, is we've created a lot of guides to help the public. And you can go on our website and you can find advice for how to do this for yourself, how to get into it, what to know before you go out. There are also some practical tips that might help you in the field, like letting your eyes adjust to the dark, giving it at least 3 hours as you watch for the aurora to try to present itself. It is rare in Michigan in the Great Lakes region, so giving it more time is better.
Well, that's, as astronomers, we let our eyesight adapt to the dark so that we're able to see more, and
that's really
so
great.
good sage advice.
Yeah.
And as you say, being out in winter as amateur astronomers, wear more clothes.
Right.
You can always take them off.
Yep, layers are helpful.
Exactly. So you talked about founding Michigan Aurora Chasers back in 2021. Can you tell us more about your group?
Sure. The Michigan Aurora Chasers is a community that now numbers over 128,000 members in Michigan and surrounding areas.
Oh, my.
And whenever the aurora are active, the Michigan Aurora Chasers, which began on Facebook in our Facebook group, will post live sightings when the aurora are out. These live sightings not only tell your neighbors when they might have a chance to see the aurora. If it's happening in a city near you, you definitely have a chance. But they're also really good for citizen science. So researchers are looking at some of these aurora images when we submit them to organizations like aurorasaurus.org or Skywarden, and they're comparing these images to reports of sightings in the sky to learn more about the aurora, the different formations, and what's out there to discover. Even the subaraural arcs Steve and the picket fence were only given a name in 2019 when they were famously discovered by the Alberta Aurora Chasers, which is another Facebook group.
Okay, so there's a number of these types of Facebook groups around North America?
There are, and we're not only on Facebook, we do a lot in the community as well, and we now have live alerts on the Telegram app. You can learn more about that online on our website. But many communities have formed trying to help each other know when the aurora was out. Way back in the day, I heard that people used to just call each other on the phone and they'd have a phone chain. And, you'd wake everybody up to get them outside when there was a sighting. Maybe they did that for fireballs and meteor showers too.
Yeah, there you go. So it's it sounds like an organization in general, beyond just for Michigan, but a large group, we say, of citizen scientists that help alert folks and disseminate knowledge.
Absolutely. Yeah, Aurorasaurus is actually a citizen project, citizen science project funded by NASA, and it's run internationally. The Glendale app has also been accepting a lot of citizen reporting on auroras, and that's international as well, based out of the UK. So there's a lot happening with that for sure.
Okay, so it's quite a network.
It is.
Now, can you tell our viewers about what the Aurora Summit is?
Absolutely. So when I first got into aurora chasing, I did everything I could. I read all the books, read all the reports, studied whatever I could find, and learned how to do the forecasting. But I joined these communities hoping to learn more and hoping to get real advice from real people who had been out in the field and seen really good Northern Lights displays. One of the groups held an annual gathering where everyone got together to chase the aurora together each year in the Great Lakes region, and that became the Aurora Summit. It got too big for a small town. We needed a place to take everyone for dinner and a hotel to sleep at night, and so we turned it into a convention. Anyone is welcome to attend. The Aurora Summit is held annually. It's open to the public. Our tagline is celebrating the art, culture, science, and photography of the aurora. And we bring in a keynote speaker. We have educational sessions. We provide 3 days of activities, including a pre-conference photography boot camp where you can learn how to dial your camera in for a weekend of aurora photography. So that, let's see, registration opens for the Aurora Summit every year in June, and people can learn more at theaurorasummit.com.
Okay, typically when is that held?
Yeah, we've been holding it every year in the fall. We're aiming for the first weekend of November every year. And so in 2025, the Aurora Summit will take place November 7th through 9th, 2025.
Okay, all right, great. So hopefully folks will get onto your website and check that information out.
Yeah, they're
What
welcome
other
to
types of events are you involved with the Michigan Aurora Chasers?
Sure, yeah. Our community loves events. We love opportunities to get together and to learn and to share and to look at all this beautiful aurora photography and aurora time lapses. So we are doing a lot of events. We are starting this year, actually tomorrow night, as you and I are talking. We're actually speaking in April. So in April, we'll be launching our first Michigan Aurora experience, and I'm going to be leading a group of aurora chasers out into the dark without much knowledge of the aurora forecast until right before we get out there, and without much certainty in the weather forecast until right before we got out there. We planned this over a month in advance and invited people to come out chasing with us, and so I'm going to lead a guided chase in northern Michigan to try to find the Northern Lights, and I bet that we'll catch a sighting. So that's called the My Aurora Experience. We also lead what we call the live chase. When we know that aurora is active, and when we know that there's a really good chance that people can see the aurora dancing above Michigan on any given night, we will host a live chase. We'll bring people out on short notice, and we'll lead them right to the Northern Lights and teach them how to take photos of it too.
Great. Now, do you give talks to various community groups?
I do, yeah. It started with presenting at the Michigan Aurora Workshop, which sells out really quickly every year. But now I give talks around the region. I've visited the Upper Peninsula and the Lower Peninsula, talking about how to forecast aurora, how to chase aurora, and how to enjoy it for yourself and see it with your own eyes.
Well, that sounds great. In the minute that we have left, is there anything else you want to tell our guests?
Sure, yeah, check us out at michiganaurorachasers.com, and I also wrote a book. It's a guidebook, Beyond the 45th Parallel, the Beginner's Guide to Chasing Aurora in the Mid-Latitudes. That will get anyone started on their aurora chase.
And they can find that at various booksellers online?
Yep, absolutely.
All right, great. Well, Melissa, I want to thank you very much for being on the show to tell our viewers about your amazing organization and the chance that they can have to see the aurora for themselves. Please visit our club website. The address is down there at the bottom of your screen. And coming up next with What's Up in the Night Sky, is Stephen.
Thanks, Don. What's up in the night sky for June 2025? The sun moves from Taurus to Gemini over the month. You won't be able to see that because, it's the sun. Sunrise and sunset don't change much over the month because June 20th is the solstice, winter or summer solstice, depending on your hemisphere. But near the solstice, the day lengths don't change very much. They don't change very fast. June 3rd has the first quarter moon. The full moon is on the 11th, the third quarter is on the 18th, and the new moon is on the 25th. Then we have Mars and Mercury shown at the end of the month, just a little bit after sunset. So Mercury goes from Taurus to Cancer, and Taurus is where the sun is at the beginning, and it sets from about sunset at the beginning of the month to 2 hours after sunset, shown here at the end of the month. And then we have the moon. We have the moon also on the 30th, but Mars is in Leo and sets about 4 hours after sunset. And then we have Jupiter, Uranus, Venus, Neptune, and Saturn, but we're going to just talk about the first three. Jupiter goes from Taurus, again with the sun, to Gemini. Jupiter has superior conjunction on June 24th, so Jupiter is in the trees, in the grass, at best, all month. Uranus is in Taurus, so it's awful at the end of the month, at the beginning of the month. So at the end of the month here, as shown here, Uranus rises 3 hours before sunrise. That seems like a lot. Maybe it's only an hour. But anyway, and then Venus goes from Pisces to Taurus and rises about 3 hours before sunrise all month. Venus has max western elongation on the 31st, but it's still good at the end of the month. And then finally we have Neptune and Saturn and Pluto. And we had Neptune and Saturn already, but now we're going to talk about it. Neptune and Saturn are very close to each other, and they both rise from 4.5 hours to 6.5 hours before sunrise all month. They are in Pisces. And Pluto is in Capricornus, and it has meridian transit, which is when Pluto is highest in the sky, and it's a faint object. You're going to need probably a 12-inch telescope to see it. So it has this meridian transit about 3 hours before sunrise to 5 hours before sunrise over the month. And that is what's up in the night sky for June 2025. Remember, we don't charge money for this show, but we may tax your brain.